So far in this unit, we've been looking at expanding and multiplying out polynomials. Now we're going to start factoring or dividing them out, breaking them up into their factors, their greatest common factors. So as a quick refresher, recall that factors are numbers that divide evenly into a specified number. So in this case here, I got 1, 2, 3, 4, 6, 8, 12, and 24 are all factors of 24. You could divide 24 by any of these numbers and get an even number. In general, we don't usually work with the 1 and the number being factored, so we usually don't use the 1 and 24 in the cases that we're going to be working with, but they are technically factors. Also recall that the greatest common factor, or GCF, is the largest number that divides evenly into two numbers. So 3 is the greatest common factor of 9 and 12. It's the biggest factor of both 9 and 12 that works. 5 is the greatest common factor of 5 and 20. 5 is a factor of 5. 5 is a factor of 20. It's the largest one. 1 is the greatest common factor of 7 and 8. That's the biggest number you can divide both of those by evenly. So to factor a number, when we're asked to factor a number, what we mean is that we're going to break it down into the prime factors that compose it. Recall that prime factors are numbers that are divisible by 1 and itself. So if we factor 6, the prime factors of 6 would be 2 times 3. 2 can only be divided by 2 and 1. 3 can only be divided by 3 and 1. So there we prime factors, found the prime factors of 6. Now 18, well, that's made up of 9 times 2. But 9 isn't a prime factor. 9 can be broken down as 3 times 3 times the 2. And so there we factor those down to their prime factors. 3 times 3 times 2 for 18, 2 times 3 for 6. You can think of this as undoing multiplications, so you can think of this as undoing expanding in terms of polynomials. So we're going to do some examples here. Let's take a look at the first one here. That is a 6. You'll see why in a moment. We're going to expand and then factor. So let's expand this out. 3 times x, 3 times negative 2. 3x minus 6. So when we expand it, we've multiplied both terms by 3 to get this. So we're just going to undo that when we're factoring it. So this equals exactly what the question was. 3, the number, that's the factor. In this case, it's the greatest common factor of these two. And then we're left with x and negative 2. We're dividing each of these by the 3. So if you want to see a full breakdown of that, 3x minus 6, we're factoring out the 3, so we have to do x divided by 3 minus 6 divided by 3. Or sorry, 3x was in there. 3x divided by 3. So the 3's will cancel, and then that will become 2 over 1, or just 2, and thus we got the 3x minus 2. So we're actually dividing out that 3. Sorry, there you go. Now you can see it. So we're actually dividing out that 3. All right, so that's what we did here. We're taking each term and dividing it by the common factor. Here we were multiplying each term by that factor. Here we're dividing out whatever factor we selected. Let's try this next one. If I expand this out, I have negative 10. 2 times 5. Gx squared. So that's that first part. Minus 6 x squared y squared. Okay. So there that is. We're going to factor it now. So the common factor between negative 10 and negative 6 is negative 2. Common factor of x squared, they both have an x squared in them. And that's it. There's no other number we can divide out of that. No other letter we can divide out of that. So we're left with Negative 10 divided by negative 2 is 5. The x's will cancel, and you're left with g. And then we go to the next one. Negative 6 divided by negative 2 is going to give us positive 3. The x's in this case will again cancel, and you're left with y squared, which is the same as this. Again, we're just reversing these each time. So a few more examples here of factoring. Here's a larger one where we have 3 terms, so we got to find a common factor for all 3 terms. 12, 10, and 14. The largest number that will divide into 12, 10, and 14, 2 will go into all of them. That's the largest one that will go into all 3 numbers. This is m to the 5. This is m to the 2. This has an m to the 3. So we know m is going to go in. The most m's we could take away is 2. That will leave m to the 0. So we're going to factor out m to the 2. We just look for the lowest power on the m's. They all have an n, so I'm going to put the n down. And again, we look for the lowest power on the n, which is 3. When we divide that out, those n's will cancel each other, and it'll still leave some here. So there's our common factor, 2m squared n cubed. And now we divide everything out. Numbers divide by numbers. 6, m to the 3, n's are gone. Negative 10 divided by 2 is going to be negative 5. The m squareds are going to cancel, and the n is just going to be left with 1, 4 minus 3. Finally, we have 14 divided by 2, that's 7. M cubed divided by m squared, going to leave me with 3 minus 2, or just 1m. And n to the 5 divided by n to the 3, 5 minus 3 is going to give me n squared. Now you can always check these answers by expanding this out. If you multiply this back out, you should get to this result here. And so that's a way to check it. Now, there are some situations where factoring looks a little bit different. In this case here, we have 5a being multiplied by a plus 3b. And then we have positive 4b being multiplied by a plus 3b. This a plus 3b is common. It's a factor. It's not a single number factor. It's a binomial factor, but it is a factor, and so we can factor it out. If we factor it out, we would have a plus 3b, and then dividing it out from here, it would remove it here and be leaving 5a. And then over here, it would remove it from here and leave the positive 4b. And so you can factor out a common term like that. A common binomial like that. Doesn't have to be an individual term like this here. That's going to be useful when we get to these next two. So these next two are a little bit different. If we look at 10, 15, 8, and 12, they don't have any common factors. P squared, P, no common factors. But if we look at the first pair, they have a common factor, and we look at the second pair, they have common factors. We will do what's called factor by grouping. So we're going to group the first pair. 10 and 15 have a common factor of 5, and then the P, we're going to be left with 2P minus 3. Whenever we do factor by grouping, whatever sign is in front here of this next term, put it down here. Okay, so that sign just gets dropped down. Common factor between 8 and negative 12 is going to be 4. And when we divide that out, we're left with 2p minus 3. Both these brackets are the same, 2p minus 3, meaning it's a common factor, just like in part B. So we're going to factor that out. We're left with 2p minus 3 times 5p plus 4. That would be that factored. This is going to be useful. If you notice, we could combine those middle terms and get a trinomial. This is going to be useful when we're factoring trinomials in the next section. One more example with that. So again, 9, 12, 12, and 16. Oh, they have a common factor. They all have a common, or sorry, they don't have a common factor. So what do? We factor by grouping. Pick our pairs. Common factor between 9 and 12 is 3 and then m. We're going to be left with 3m minus 4. Bring down that sign, which is negative. Common factor between 12 and 16 is going to be 4. Bracket. Negative 12 divided by negative 4 is going to be 3m. There, positive 16 divided by negative 4 is going to leave me with negative 4. So I am using that sign when I'm factoring it out. 3m minus 4, 3m minus 4. Common factor. Well, looky here, we got ourselves a perfect square trinomial. So this is 3m minus 4 squared. So again, when we're factoring, look for common factors first. If you can't find a common factor, try factor by grouping methods and looking for binomial common factors as well. There are cases where you might not be able to factor because not everything is factorable.